Welcome to part 3 of the Perepiteia demo video series. What we're going to be demoing today is something similar to what you've seen on the other videos, but now what we have is our high voltage coils, which have been separated from the same core as was previously demoed. Now we have a high voltage coil 2 and high voltage coil 1, which are on different sides of the rotor. We have 5 stacked magnets here, and we're taking our high voltage off of both sides of the rotor. We have our high current coil here. High voltage coil 2 is 90 ohms, 30 gauge wire. High voltage coil 1 is 53.3 ohms, 30 gauge wire. And then we have our high current coil here, which is 4.5 ohms. And what we're doing with this is our test bed, and what we're doing is building and testing various high voltage coils to determine which ones give us the best performance. Now what I'll be doing here in this test is loading these high current coils through a 10 ohm load and showing the deceleration effect according to Lenz's law. And then I will compensate with one high voltage coil and then the other, and we will see the compensation effect for the deceleration with acceleration from our high voltage coils. So I will start the system now. Our prime mover is rotating. We are on no load right now. We have high voltage coil 1 volts here, high voltage coil 2 here. We have our 10 ohm load and the voltage across the 10 ohm load. Now I'm just going to bring our prime mover up to a reasonable speed there. Now what I'm going to do is I'm going to load our high current coil, and as we should expect, we should get deceleration. So there's 1.8 volts across our 10 ohm load. And it's dropping ever so slightly. I'm going to introduce high voltage coil number 1. And we get a little bit of acceleration. Now high voltage coil number 2. So we're up to 2.5, 2.7 across our load. 3.4, 3.5, 3.7, 4.4, 4.5, 4.9, 5.2, 5.3, and I think that's high enough. So, as you can see, I'm going to turn it back on. I'm going to take the high voltage coils off again. I'm going to take the high current coil off.